Skeptic, Graphs and Networks, the podcast exploring how the graph data structure has an impact in science, industry, and elsewhere. Welcome to another installment of Data Skeptic, Graphs and Networks. Today we're talking eGaming. Let's start here. Asaf, are you a player of Sky, Children of the Light?
Actually, I'm a person in not such a gamer, unless you count losing in online chess, which I do a lot.
You know, I've been somewhat familiar. I never played this game, but it always looked kind of cool to me. Today we're talking to not someone directly related with the game, but a USC student who got to do some analysis on these games, in particular studying behaviors of generosity. Is that something you find elsewhere in network science?
Yes, actually, some of his work is echoing Nicholas Christakis' research. Nicholas Christakis is a famous network researcher, social network researcher. Christakis' work is mainly about, let's call it, percolation of behavior in networks, such as also generosity, but also obesity, smoking, and other vices. He's trying to show that behavior percolates in the network. If you are, let's say, you are a smoker, the chances that your friends will be smokers too. You know, we all talk about correlation doesn't equal causation, but Alex makes a good point when he's talking about causal inference.
The other interesting idea Alex touches on is the notion of contagion, that not only through those causal inference techniques do they establish that generosity has positive impacts on user behavior, but that people near good behavior will echo it. Sort of in the way, I guess, disease transmission works, or would you look at it differently? Can we model it in the same way that the flu spreads?
Network science deals with all kinds of models of spreading on networks. Every virus or every disease has its own beta, the rate of its infection or transmission.
Is beta the same as R naught?
Exactly. It's from the same vocabulary. So it depends. Don't know the model for generosity. There could be more. I guess flu is, I can talk from first hand because I have the flu now. I don't know if you can hear it. So, and I think I experienced more flu now than generosity. If we're talking about transmissions and things crawling in the network, another interesting point that Alex makes is that two models. One is reaching out for strangers, and the other one is strengthening connections with close friends. So in network analysis, we usually call it the strong and weak ties. This reminds me, of course, of Mark Granovetter, who's a famous social network analysis researcher, who published, I think, the most the most cited paper in social network analysis and the strength of weak ties. It's a very famous paper. I think it was published in 1974. He talks about the importance of weak ties in the paper's case of getting a job. Because when you use only your strong ties, you don't get new knowledge. You need weak ties, let's say college ties, or to get another job, to get more information in the network.
Well, I think gaming gives a unique opportunity to study some of these things because A, it's all digital. As long as the tracking's set up correctly, they have all the analytics. Nothing's offline like disease transmission where you can't really know. And when there's millions of players or however many playing, a lot of data. So I think a big opportunity here for a lot more network science insights to come out of gaming. Are you familiar of this other case in gaming where World of Warcraft tried to experiment with putting a virus into their game? Not a computer virus, a sort of contagious virus.
Well, I heard about it, but as I said, I'm not a gamer, so I'm very interested to hear your point of view about it.
Maybe we should do a follow-up episode on that after people get excited about this episode on gaming. But to my understanding, the high level of it is that the well-intentioned game designers over at World of Warcraft put in a virus that when you got close to someone who had it, you could catch it with some probability. And the parameters they selected for this virus enabled it to spread everywhere quickly. And like 99% of the population was infected in a short period of time. And it was sort of a disastrous moment for the game, perhaps, or maybe a very exciting moment for the game, depending on your perspective.
The problems with high beta, as we see.
Yeah. I guess a lesson learned there.
I am Alex Bisberg, currently a fifth year PhD candidate at University of Southern California. I study social and competitive success in multiplayer online games, and I study this through networks, machine learning, and AI.
And what's a social and a competitive success?
So, in my mind, as someone who's played a lot of games, games are very useful for not only personal enjoyment, but also for studying human behavior. Games are sort of resource constrained environments, especially multiplayer online games, where people tend to collaborate together. A lot of multiplayer online games have matchmaking systems where you end up matching against another player or group of players. And in my mind, the capacity for an individual or a group of people to do better or vanquish this other group would be sort of competitive success. The other more subtle aspect of multiplayer games would be social success, which would be the capacity for a team or group to communicate, work together, and sort of have those a little more intangible facets than just destroying their enemy or completing the task at hand.
And I think there's a pretty broad taxonomy of possible games from, I don't know, card games or game theory games all the way up to online multiplayer games. Where's your focus primarily?
The two that I will focus on for my research, and I'll start with the one we're going to be talking about today, called Sky, Children of the Light. Sky is a multiplayer online game where you explore levels and partner up with other players to basically accomplish tasks in the level. So it's a collaborative online exploration game.
So Sky, Children of Light, you've already mentioned it's an open 3D world. You can fly around. So I kind of get it intrinsically, but could you share a bit more about the gameplay?
The unique aspect of Sky is its intrinsic mechanic to level up your friendships with other players. So instead of a typical game, maybe like a role playing game where you would level up your character and you would sort of gain power throughout the game, instead you actually level up your friendship level with individuals in Sky. And in the beginning, they actually appear as silhouettes. So there's less identifying information. You can't see how the player has chosen to represent themselves. So I think this is a really cool way to motivate players to connect with each other without having sort of the component of identity or progress in the game. You can actually customize your character, get cosmetics, and you can increase your capacity for wings or basically flying, a metric of progress in the game that you can basically fly further, explore higher places that are harder to reach because these levels are very vertical. Throughout the level, you can encounter spirits, which also give you unique in-game emotes you can do, which are very fun, and you can do them with your partners as well. To summarize, basically, mechanics are social interaction between players, like an exploration of the level, and then competing for spirits. The end game is facing these large monsters called krill, which are very sort of spooky, and you have to be very creative about how you how you escape from them, basically.
And you'd mentioned that data sharing agreement. That sounds like an interesting opportunity. Could you share a few details about what the raw data is you have access to? Like so many of you out there, I love Notion, our sponsor today, and I use it every day for notes, docs, and project management. It's a great tool, and I'm going to assume most of you have already tried it, because today I want to tell you about the new buzz around AI, specifically what Notion has just launched in their new incredible tool, Notion AI. Notion AI helps you work faster, write better, and think bigger, doing tasks that normally take you hours in just seconds. Everyone's aware of the recent advances in large language models, and Notion has one of the most impressive rollouts of it. They have some really cool other tools like helping you rewrite a paragraph to sound more professional or more casual or one of the labels you choose. Just tell Notion AI what to do, the more details the better. Have it write a blog post, make an outline, brainstorm ideas, or summarize a whole bunch of documents. Notion AI is an impressive choice for writing, summarizing pages, finding action items, inline translation, and whatever you need to have the IDE for running your life. You can select any text in Notion and click Ask AI. For a limited time only, try Notion AI for free when you go to notion.com/dataskeptic. That's all lowercase letters. Notion.com/dataskeptic to try out the incredible power of Notion AI today. And when you use our link, you're supporting the show. This is a limited time offer. Try Notion AI for free right now at notion.com/dataskeptic. Could you share a few details about what the raw data is you have access to?
We are very fortunate to have access to basically a full database of game logs. The cool thing is that this data is fully anonymized. And so as a researcher, I don't know, the identity of any of these people. And we also have established what's called like an IRB, basically an internal review board with University of Southern California, just to make sure that, we're handling all the data correctly and it's anonymized appropriately. And the players also know that, they could opt out of data collection as well. And so the data itself is a lot of pretty low level log data, which is cool. So we have access to how often they're playing, which levels they're playing. Are they playing alone? Are they playing with strangers? This, I guess, will be helpful to describe. When you enter into the world of Sky, you enter into a lobby where you can kind of then determine if you want to go into explore, let's say, what's called like the prairie or the rainforest. And there's kind of these different levels based out of the home lobby where you can also interact with other random players that you don't know. And we would call these strangers. Or you could enter into a session with your friend, which is someone you would already know. We have access to that data of like whether you're playing alone with friends. And then to form this relationship in Sky, as I was talking about, you actually gift someone a candle. And this gifting interaction is pretty interesting feature. And you're almost giving away your in-game resources to level up your friendship with them. And that's something that we study in the work we're talking about today.
Does this candle giving, or does a candle itself have any intrinsic value, or is it just sort of a currency?
It is valuable in terms of time because you can forge a candle through gathering light in the environment. So you basically gather the light and you can change your light into a candle, and then you can give those away.
Why not keep them all for myself?
I think you could transfer them to hearts, but you actually can't convert your own currency into basically the currency that unlocks you cosmetics. I think you basically could either pay real world money, or by exchanging these candles, you can actually gain the currency to like level up your cosmetic upgrades. So it's basically a way to motivate players to, I think, get to know each other and collaborate without necessarily, just like sort of pay to win. Not pay to win, but like you can't just like throw infinite money at it for yourself.
Well, I've never had the opportunity to work on game log data, but I've worked on a lot of log data, and usually it's extremely verbose, like character moved from XY1 to XY2. Do you have to do any pre-processing to make it useful?
We're so fortunate to work with this awesome data engineer at that game company. I'll give her a shout out, Tina. She's very cool and really takes care of us in terms of she moves the data from their production database to a Google Cloud BigQuery database for us, which is awesome. And they have used a couple of different logging platforms. I think it used to be Firebase, and now they moved over to Starwatch, which both have been great. It's cool because she'll dump basically the raw logs, but also has done some pre-processing for us, converting what would be like a large dictionary of values like XY position, number of actions taken, number of friends, a lot of that stuff has basically been normalized out into columns in the database, which is super nice for me.
Well, where does machine learning and AI play a role here?
So we've given the background for the game, and we've hinted that generosity is important in this game. I think my goal is to, create more harmonious behaviors online. I think that's relatively straightforward for a lot of people to understand. But on top of that, I think if we show that incentivizing good behaviors actually leads people to play the game more, then this is a great way to convince companies that we can actually integrate these mechanics into the game and not lose money. So my goal was to actually see if we could predict if people will play the game more and be more generous in the future using this log data. And machine learning helps us make better predictions.
How do you define generosity mathematically?
I think for us, generosity is something pretty specific. In Sky, we have a very easy mechanical action where I'm giving away a candle or effectively sort of sharing a candle with someone. And obviously, a very simple way would be just the count of the candles that I'm giving away. So I guess quantity of candles.
Is that something a player can do anytime into any one, or are there some constraints on it?
The gifting can happen as long as you have currency. The neat thing is you can gift a candle to a stranger. And in this case, strangers appear as silhouettes. So I actually don't know who I'm gifting to. So that is one thing that I've worked on studying a little bit more in my future work, past what we're talking about, versus some people prefer to actually gift things to their friends. And some people will be more interested basically in building those relationships with people they've already met, whereas others are interested in forging new relationships and giving things away to people they don't even know. So these are kind of two different modalities we can see in this one game.
So I'm trying to picture some of the data set. There must be like a gifter user ID, a recipient user ID, maybe a number of candles and a timestamp. What else is important for your analysis?
You're definitely thinking about it the right way, where we have, like gifting ID, recipient ID, and then the timestamp that it happened. So we use like the total number of days that someone's been playing, the duration they've been playing, and the sessions they've been playing. We have daily aggregated numbers, which are nice to work with, especially if we're doing this at the level of like predicting this for a certain time frame. So I will basically aggregate those daily counts to get the total number of days, the total duration they played the game. We define a session. This is the Sky's concept of a session, is basically a unit of gameplay that has over a 1 minute gap between it. And we also have basically social data, which is at that session level data. So we have basically a column that says, was the session social? Like, did I play with a friend? Did I play with strangers, or was I playing solo? So that is also aggregated at the session level. So that's nice. If we're basically predicting your subsequent session, it's really easy to summarize the data at a session level.
Are there any immediate patterns that jump out? It seems to me maybe I'd be more inclined to give a candle to a friend than a stranger, but maybe not.
So what we showed is that if you're playing with a friend already in one session, you're more likely to play longer the next session, explore more levels, and also find more in-game currency. However, you're not as likely to make new friends your next session. This does sort of suggest that if you have a group of friends you're playing this game with, you are already more likely to stick with them. Conversely, if you play with strangers, you're actually more likely to make new friends your next session. So people are more interested in finding new friends when they are matched with strangers. And in terms of generosity, if people have received a candle, they're actually more likely to give a candle their next session as well.
That seems somewhat intuitive. I guess in the paper you described that as a contagion. Could we zoom in on that? How do you think of contagion, again, maybe mathematically or maybe just structurally? What does it mean to be contagious?
I think contagion is sort of a phenomenon studied in social sciences. basically the phenomenon of how other people's interactions influence other behaviors. I guess the word contagion does come from disease outbreaks. If you're proximate to someone, you might literally catch their disease, right? It'll be contagious, which, has a negative connotation. And then the jump can be made. Well, if bad things are contagious in the real world, can behavior like social behaviors be contagious? And there's a big body of work that shows that this is true, in that there's social contagion online. We've seen this a lot in social media. Like a lot of my other lab mates, a lot of my other colleagues work on social media. And maybe many of us have, experienced firsthand the sort of polarization that happens on social media and the way that ideas are shared. Our idea was, could we operationalize this social contagion and see if it happens actually in a positive way? So are the way that people are behaving inside a game actually cause people to change their behavior? The cause is actually a pretty important word here, because human behavior is extremely complex, and using a normal statistical analysis might not capture the whole picture, right? If we're studying a lot of different variables, like, the playtime and other things like that, maybe I was simply just playing a lot more and I got a lot more resources. So I figured, I might as well just give this stuff away and I'll have use for it. But we actually use a stronger technique called causal inference to try to convince the audience that the behavior is the thing that is contagious. It's a tool we use when we have these types of massive data sets, but we didn't actually perform a controlled experiment in the moment. One way that science functions well, especially when we're doing experimental design, is we can set up a control group of, let's say, people who don't receive a treatment and compare it to the effect of people who do receive a treatment, effectively isolating the variable. And what causal inference allows us to do, it lets us set up what we call a pseudo experiment. This is possible when we have a large enough data set where we can basically separate or stratify people based on their sort of exposure or observed behaviors. And then we separate them based on the treatment, which in this case would be generosity, which we believe has the causal effect.
Well, I guess if we approach it scientifically, the null hypothesis is that generosity doesn't exist or has no impact. I'm not sure which. What sort of statistical test do you pick to measure if it's there or not?
Statistical analyses are important to then determine, let's say, differences in distribution. So we'll do that first to describe the data. And this is kind of what I was saying, where we have statistically more players who play after experiencing social connections. And then we move into the predictive analysis, where we would use causal inference to make a prediction. In the statistical analyses, a lot of us have heard of, in our entry-level stats class, the student's t-test. The student's t-test is actually what we would say where the mean of a certain variable is statistically significantly different than the mean of another variable. There is actually a key assumption here that the data is normally distributed. And I think this actually is something that we forget about sometimes. In this case, we actually have non-normal data. Basically, this means that the data is very skewed in online games and a lot of online networks. There is a large portion of the population who doesn't interact or doesn't offer candles, and then a much smaller portion that does. So we kind of have these long-tailed distributions. So for this, we use what's called a Mann-Whitney U, or basically a non-parametric hypothesis test.
And then what are you testing for in that case?
In the hypothesis test, you're testing if the mean of a distribution is significantly different from a mean of a different distribution. And to give you an example, basically what we show is that the mean total playtime of someone's subsequent session is significantly higher than the mean of someone's total playtime if they didn't play with a friend. This is basically showing that given this variable, is there actually a way that we could say based on the distribution that it's higher than the other one? And it is, which is cool for a couple of different fields.
So I've heard this story at Facebook that at some point someone determined in order to be successful on Facebook, you had to get to 20 friends or something along those lines. And it's not like, 19, you were failing out. There's a gradient to it, right? Just as in your case, you're dealing with distributions that are difficult to summarize. But do you have a rule of thumb along those lines? Is it doubling playtime, 30 seconds more? How does it fall out?
If you play a friend level, you'll probably be playing about 10 minutes longer in your next session. This gets a little bit into like the mechanics of the platform. In Facebook, maybe your network size of 20 is sort of semantically useful to establish that you are now not only ingrained in other people's feeds and you're understanding, you're seeing a lot more of what they're posting. It kind of leads to this snowball effect. And for Sky, I would see playtime as like, I think 5 minutes is kind of not enough to do a lot in the game. But when you start getting closer to 10 minutes, I think that's like a pretty meaningful difference. You could gather in-game currency called wax. You could fly around the level. You could do a collaborative task with someone new that you meet. It is a pretty significant chunk of time more that you're playing, which was also pretty exciting.
Can we explore more of the contagious nature? Do I have to be a recipient before I, as you might say, pay it forward? Or could I just observe generosity and then it becomes part of my behavior?
That is one of the more exciting findings, I think, from this work, is that we tested not only to see if you received the candle in the time frame to then predict if you would be more generous in the future, but we saw that players who were simply nearby other players giving candles were also giving more, committing more generous acts in the future. So this is called third-party influence. Players not only were more generous in the future if they received a candle, but were more generous in the future if they observed people gifting candles. And we would call this third-party influence, which is a phenomenon that's been studied before, but not as directly and quantitative in this way.
Well, I think there's a lot of value in the analysis from just sort of the social side of it, looking how a network of players interact and some of the phenomenon you've discovered. But I'm curious if you think any of that will circle back around and influence the game designers in some way.
That is definitely the hope. I mean, I would consider this game sort of a pioneer in that the way that it encourages these gameplay loops and social actions is definitely ahead of its time. I think game developers should take this work and think to themselves, are there ways that I could, get my players to be more generous, because it will help them form social networks and this generalized reciprocity to, I think, almost humanize their player base. Because one of the problems I think some online games have is maybe more sort of toxicity happening in terms of, verbal or text-based communication. And I think a really good way that's been shown to reduce this is to humanize people and make them feel like, there's a face behind the character on the screen. And generosity and giving away resources is a great way to connect with people and humanize them and kind of have this reciprocal relationship that not only is pro-social and good, but we've shown makes people play the game more, which is maybe like a key KPI, right? Or like a key performance indicator for a lot of game companies.
And we've touched a little bit on the predictions you're able to make. Could we expand upon that? I think you touched on the methodology, but could you share a few more details on what you're predicting and the metrics you use to evaluate the quality of the prediction?
We talked a little bit about hypothesis testing, and now for the prediction, I'll go back to talking a little bit about the causal inference technique we use called propensity score stratification or propensity score matching. That's kind of how they're used interchangeably. And basically, what we do here is we find groups or pairs of players that are most statistically similar in terms of their covariates. So the covariates are factors like their seniority, their social engagement, their progress. So how many levels have they explored, other nearby players, and if they've played in groups or alone. And then the treatment variable is if they received a candle in a previous session. The outcome variable is we predict, right? We basically predicted 3 outcomes. So will you return in your subsequent session, in your subsequent, let's say, time frame? How many sessions will you play in that time frame, and how many candles will you give in that time frame? To summarize, we have propensity score stratification that is stratifying our groups of users in one time frame, and then we're predicting an outcome in a second time frame using this technique of causal inference. All 3 of these predictors were significantly higher for players who received a candle in their first session.
So there's a not super long, but couple decades long history of the social sciences and network science looking into similar topics. Where are we in the state of scholarship on this? Is it early days, or is there an established literature?
I would say that in terms of the broader scope of research on social contagion, specifically in games, I think this paper is relatively new and pioneering. I think especially because this particular game has generosity as such a core mechanic. I think there are gifting systems in other games which do require like real world currency, let's say, to purchase, let's say, like a cosmetic item, and then you could gift that item to someone else in the game. And this is actually something that I experienced when I started gaming. Was one of my friends, when I was playing this, and this is a game that's been around a long time and been studied a lot, is called League of Legends. One of my friends gifted me a skin in League of Legends, and it got me really excited about the game, and it wanted me to make me play more. People have studied, I think, some interactions in games like League of Legends where you actually have to pay for the gift with your own money. I think those situations are a little tougher to motivate because players do realize that that is their own money and it's a little more like tangible. But the interesting part here is that if we gave players, and this is a research question I haven't been able to answer yet, but like if we gave players some small amount of currency, let's say, but we told them it was only able to be used for gifting, would the amount of money we lose gifting them that currency, let's say we lose like X amount of money from giving a player some amount of in-game currency that they could have bought otherwise, right? Is that small amount of money we lose actually less than the future gains we get from that pair of players, let's say like playing together or then going on to spend, let's say, more money? So this would be like, I think, like a really interesting follow-up study to see if that type of more monetary generosity will actually benefit.
Well, Alex, what's next for you?
I'm actually in my final year of my PhD, which is cool. And I'm interested in becoming a professor. So I'm currently applying for faculty jobs, both teaching faculty and research faculty. So, yeah.
And is this directly something part of your thesis? Or I guess my question is, what's your thesis exactly about?
Yeah, you're right. This is definitely part of it. And as I hinted in the beginning, zooming out, we have competitive success and social success in online games. I have a little body of work that is also devoted to competitive success. And after this, I've now worked on basically building a taxonomy for these social and competitive interactions in online games. And a taxonomy basically helps us determine who these players are. And it'll show that almost making a personalized recommendation for the player based on how they interact with others and what their goals are in the game will actually help make better predictions about them. So my goal is to use network science, basically graph neural networks to make predictions about how players behave in games and basically learn not only from the individuals, but from the communities.
And in that professor role, I imagine sort of academia and game analysis is somewhat new and emerging. What does that look like? What even department do you see yourself fitting in?
Even right now at University of Southern California, we're split between a few departments. We have computer science, which is where I work with Emilio Ferrara and the Humans Lab. He's my main mentor. But I also have these great collaborators in Annenberg Game Lab with Dimitri Williams and his group there. This is actually the School of Communication. We have folks there thinking about games from a more, communication, co-play, theories about the way that people communicate and interact, doing really cool stuff with surveys and interviews. And we sort of build on that using the quantitative side of things, helping them with the data analytics and the machine learning side. So I would ideally like to be in computer science, but I think my research interests could also be generalized to, networks and groups of people in general. I would hope to pitch myself as a games-focused researcher who uses a lot of methods from network science.
Is there anywhere listeners can follow you online?
I am unfortunately not very active on X, but you could definitely follow me. I think I will try to post there a little more at It's the Business. My last name, Biz, Bisness. I have my own website too. Definitely check that out. I don't update it super often, but I will try to update it more.
All right, we'll have links to both in the show notes for people to follow up on. Alex, thanks so much for taking the time to come on and share your work.
Thank you so much, Kyle. Data Skeptic was actually one of the first podcasts that I listened to about data analytics and machine learning. And I would say it definitely pushed me towards this path. So I have you to thank for this.
Oh, that's very flattering. Good news then. Thank you so much.
Of course. Thank you.